Hi, this video, we're going to be working in section 9.3. We're going to be talking about a p-value. So first we'll define the p-value. And then we'll integrate it into the hypothesis testing procedure. Okay, so a p-value is the area of the tail or tails defined by the test statistic. So a p-value is the area of the tail or tails defined by the test statistic. And over here, I have a picture of what that would be if we were working with a right tail or an alternative hypothesis of greater than. Okay, so in that case, the p-value is going to be wherever that test statistic, but this is from step 3, right? That test statistic, which has the formula. That's what the test statistic is from step 3, okay? And then wherever that is, we're just going to calculate the probability to the right or the area to the right. So 1 minus the direct lookup and from the normal table, standard normal table. That's what the p-value is, but I just wanted to also give you an interpretation of what it means. And this is in the notes, so you don't have to write it down unless you want to, but it's the probability of observing a value of the test statistic as extreme as or more extreme than what we observed. Okay, so if we look at how and by extreme we mean farther from the null hypothesis. That's what that means. So if we look at the numerator of the test statistic, we can see it's a measure of how close the sample mean is to the population mean. I mean, to the sample mean is to the null mean, right? So if the null hypothesis were true, then what we would expect is that these guys are going to be close. And if the null hypothesis is false, in fact, the true value of the mean is greater, right? So we're looking in this direction. We would be, it would be because X bar was just even further away from mu naught. So the numerator gets bigger. And so we think about the area all the way to the right. Anyway, more about that, maybe more about that in class as well. I'm just going to continue here to show you how to calculate what the p-value looks like for each of our alternative hypotheses. So if we had a left tail test, then whatever your test statistic was, maybe it's here, right? That test statistic, then the p-value is going to be, because of the less than, you're going to look for the left tail. Okay, and then not a big surprise that if we had an alternative hypothesis of not equal to, then the p-value is going to be whatever your test statistic is and its opposite. So whatever that is, right, we can take its absolute. This is just whatever it is and its opposite. So this is the mathematical notation for that. But you don't have to worry about that. It's just take both tails so that they're symmetric. And then the p-value is going to be So it's the area of the tail or tails defined by the test statistic. So wherever that test statistic is, go in the direction of the alternative hypothesis. That's the area that we need to calculate for the p-value. Hi, so I just want to go back and look at the history book example in the notes. And then I want to, I'll bring that over back to the whiteboard, but I was just going to take a moment back in the notes. So just looking back a couple of pages. And I just want to remind us about this example. So the mean retail price of all history books was $43.50. And this year's retail price for 40 randomly selected history books has a mean of $46.93. The population standard deviation is $7.61. And the problem we did using the critical value approach was at the 1% significance level, do the data provide sufficient evidence to conclude that this year's mean retail price of all history books has increased from the 1997 mean of $43.50. I'm going to go to the whiteboard and put that solution back up, and then talk about how we can integrate the p-value into the hypothesis testing. So I just put up the beginning of the problem for the history book example. These were the values from the problem statement. And over here, we have our null and alternative hypothesis. So the null is that the mean price of the history books is $43.50. And the alternative is that it's greater than $43.50. We have an alpha set at 0.01. And the z, I didn't put the details of the calculation up, but we did last time. So z equals 2.85. So what I want to do is just see where we go from here. And I'm just going to repeat the critical value stuff here. Over here, I'll put the p-value because the two problem types or approaches, they have the same first three steps. So I just want to remind us what we did. So for step 4, we had to define rejection and non-rejection regions. And I had using 1 and 2, we knew that we wanted a right tail of 0.01, and that gave me 2.326. And so what I did was I took my z-score and plotted it. Oops, I guess before I did that even, I labeled my regions. This was my do not reject, the null hypothesis region, and down here was my rejection region. He comes here, right? That's my z-score, my test statistic. Okay, and because that we were here, the test statistic was in the rejection region, the decision was to reject the null hypothesis. Okay, so I know you've seen that now twice. So let me come over here and show you how we can do this. The problem, it's using the p-value approach. So first 3 steps are the same. Okay, and then I'm going to set up step 4 here. And remember how for step 4 here, we went back. And for step 4 here, we're going to use 1 and 3. So 1 tells us what the p-value region is going to look like. It says it's going to be a right tail. And and step 3 tells me where that value of that test statistic. So I know where to draw. So here's my test statistic, right? Here's my test statistic. And my p-value is the area to the right of the test statistic. So let's go ahead and find that p-value. What is the area to the right of 2.85? So it's a right tail, so it's going to be 1 minus the direct lookup of 2.85, 0.9978, which is equal to 0.002. Okay. At least you can read that now. All right. So this is my p-value. And that's the 4th step. And then the 5th step here in the p-value approach is to reject or not reject. And we reject for this step, we're going to compare the p-value to the alpha value. Okay, so in this step, we're going to use step 2 and step 4. Okay, so we're going to look at alpha, and then we're going to look at p-value. And in this, we got 0.0022. And we only reject when the p-value is small as compared to the alpha value. Okay, so in this case, because p-value is less than alpha, p-value is less than alpha, the decision is to reject the null hypothesis. All right, and if the p-value was not less, then we would not reject. Okay, and then the conclusion is the same for both sides. The test at the 1% significance level, the data does provide sufficient evidence because we did reject. To conclude the alternative hypothesis that the mean was the current year mean price of history books has increased. So that's it for this. I will see you in the next video.